So we see already some people joining the stream. So just to give first of all, welcome. But just to give a kind of a heads up, we are just giving like 4 more minutes of time for people to join, and then we'll go straight to the release notes meetup. So we'll start soon.
So in the meantime, let's say something interesting. We are working, guys, we have a lot of users that are using the data with hardware, bare metal servers, not VMs and the likes, bare metal. So we are trying to find ways, and today we realized, to monitor the hardware, to monitor more of the hardware. And today we realized that the Linux kernel has done a lot of progress to actually detect hardware issues. So I think we are going to build a hardware monitoring section in the data. We have added, today we merged the EDAC. EDAC is for error detection and correction for memory chips, ECC, the classic ECC correction on memory chips. We have already improved significantly the IPMI collector of Netdata. And today we realized that there is a tone of, even on my laptop, that's the most amazing thing, even my laptop has a tone of PCI AER, they say it. This is, let me find the name, it is Advanced Error Reporting, a PCI Express feature. So it exposes a tone of such metrics. And let's build the collector this weekend for this. That will be interesting. Really a lot of information there. Hardware monitoring. I didn't expect it, but it seems that people do use hardware still. It's not everything on the cloud.
Expect soon a collector over this.
Yeah. And probably we will gather together all the hardware-related stuff. We will gather them in a section because we have the CPU stuff, power state, power consumption, throttling, thermals. We have the memories, the memory modules. What do you want to turn off, on or off? What? Luis? The hardware detection, the hardware errors. As always with Netdata, yeah. As always, we also did another change. We started with this EDAC collector that we merged today. This thing was not showing charts until an error came up. So most people didn't realize that Netdata does monitor that thing. Right? So they believe that no chart, so nothing is there. But if an error was found, boom, the data created charts, attached alerts, did everything, and sent notifications, everything out of the blue. We did that initially in order to lower the number of metrics that we collect, store, to make it more efficient. But then we realized that people, mainly because people don't see it, they believe it's not there. So I think we should change this strategy. And actually, when we detect something, we should have the chart for it, so that the alert shows up, etc., etc. Let's see. This AER is very nice.
And probably the timings are different, right? When you took that decision, you probably were trying to minimize, as you said, the number of metrics collected. But now, with all the improvements on the DB engine and querying engine,
the idea is that in the data, if something is completely zero, all the time, not fixed, zero, it's a metric that is zero. The data zaps it. It's okay. It collects it every second, but it doesn't do anything about it. Why to do, after all? It's just zeros. But I think it turns out that this is confusing for people because they don't understand, do they monitor? Is this monitored or not? So they expect to see the chart to understand that, oh, this is monitored. This means that we will add to the dashboard a lot of zero charts. But anyway, you gain something, you lose something. Probably we need to find something more efficient for storing this zero. From storing the zero metrics. So store them in a more efficient manner or something.
Cool. So you got a sneak peek on what's coming up next, beginning of next week, maybe.
Yeah, let's see. The fact that a lot of people use Netdata to monitor hardware amazes me because it's. I didn't expect that. I thought that most of the world goes towards cloud monitoring. But it turns out that there are a lot of on-prem installations out there. And we have a lot of users, even from very big enterprises, that is surprising. At least it surprises me, that they had another monitoring solution, whatever it was. Suddenly they installed the data to try it, and they realized that they face issues that they were not aware of. Mainly because the data has this spider thing, it wants to monitor everything. So it's let's see. It doesn't sound. Although this is a little bit tricky, now we will realize that when you do LSPCI, to actually get the list in a human readable thing of what the interface is. The PCI device is, LSPCI has a database of vendor IDs, etc., that it maps IDs into human readable names. So that when it shows to you that, this interface is an NVIDIA card, this PCI card is an NVIDIA card that does this model, etc., all this line is a static database inside the LSPCI binary. It's not in the kernel, so the kernel doesn't know. It doesn't have only IDs and the driver. Let's figure out how we're going to do this. It's nice.
Cool stuff. So I think we probably can get into the release notes. So let me probably share my screen. So for all of you that are here with us, welcome and thanks for attending our release meetup. So here we are to present the release notes of the 1.41, the latest stable release that we did on Netdata. And I can go straight to the agenda. So we'll briefly start just mentioning a bit about the growth. So we keep growing, and thanks to all the support and all the users that keep trusting us and giving, as we say, love to our repo. So we have around 64K stars. We are monitoring 1.7 million nodes. And our Docker pools are increasing. We have at the moment around more than 570 million Docker pools. So numbers are looking good, and thanks for that. Then jumping to the main highlights of the release, one thing that we have been talking about last couple of office hours, if you had the chance to attend them or to see them, is the new agent dashboard. So I'll probably pass the word to Costa on this one. He can speak about it.
Yeah, just a note, because Hugo mentioned the Docker Hub pools. 2 years ago, Netdata had about 1 million Docker Hub pools a day or something like that. Then Docker Hub changed the policy, and they started charging users for the Docker pools they do. So eventually, Netdata went down, a lot down. So at some point, Docker Hub, after a couple of years, a few months ago, no, a month ago actually. So Docker comes to us and says, you know what, guys, we are throttling your pools. Do you want to unblock it, pay us this money, and all your users will enjoy a free thing? So they were throttling us to about 30,000 Docker Hub pools a day. We paid the money, and suddenly the data went up to 200,000 Docker Hub pools a day, 250,000 Docker Hub pools per day. I hope that it will go up again. So for the moment, Docker Hub pools are unlimited for Netdata. We pay Docker, so Docker has let it free. So these Docker Hub pools, they don't count against the individual user's limits. So each user has limits. It's not the repo that has limits, it's the user that has limits. Let's see. Now, let's go to the release. Guys, the release is about the dashboard. You know that, especially Luis, this is you follow up so closely lately. You know very well what we are talking about. Now the cloud, the data cloud and the agent dashboard is one thing. Is when you see in the data, you actually see in the data cloud. In order to accomplish this, we had to do a tremendous, so this is just the tip of the iceberg, you know. Below that thing, there is a huge effort to unify the API responses, the unified responses of the app. Let me show you. This is a good idea. Can you go to the San Francisco node, the demo node?
Yep, let me go there.
So to do this work, to accomplish that task, we had to actually unify the APIs of Netdata Cloud and the agent. You know, in our case, this was a little bit tougher. Why? When the cloud sends responses back, it actually receives data from agents in order to aggregate them and push them over to the browser. It needs to receive the data in a way that they are aggregatable. So if it queries two nodes or two parents, it needs to get back data from these nodes that it can merge together, it can blend together. It's not always sum, in many cases it's average, it's mean, max, whatever is there. But it needs to blend this data together to return them to the dashboard. Now, we had to develop a system where the agents are doing part of the work. They send summaries to the cloud, and the cloud is then able to aggregate further across multiple agents to produce the output. This was a lot of work. This was required for a number of reasons. One of the reasons was that before that work, so before a couple of releases ago, before April, let's say, even cloud, when it asked for data from the agent, it was asking data per node. So if you had 200 nodes, cloud had to do 250 queries to an agent. Or if it was a parent agent only, 250 queries to that agent. Take the individual responses per node, aggregate them, merge them, and send them back to the dashboard. After the work that we have done, the cloud just sends one query to the parent. If it is only one parent, then the cloud just passes through the query. It says, okay, send this as it is to the web browser. If it is more than one node that needs to be queried, then it asks the agents to return the data in a format that is aggregatable. So the agents return summaries. They don't return per node. They return summaries, including the grouping, including the filtering. So everything is done at the agents, but the responses are such. So instead of what it means, the responses are such. Instead of returning the average, if the user wants the average, the agents return the sum and the count. So the sum and the count goes to the the data cloud, and the data cloud now is able to calculate the average, even if it comes from multiple agents. It sums the sums, it sums the count, it does the division, returns back the average. So it was tricky because we had to do this kind of work for every single call, every single element that exists in the data responses. At the same time, you know that in April we released the new dashboard on this dashboard that we released today on the agent. We released it on the cloud. The work that we had done then was that we needed. Now, you have a chart. Go to a chart that has. Can you find the chart with anomaly there, Hugo, or something? So if you can find. No, wait. Let's stay here. Let's stay here. On that thing, let me resize my window to see better. So on that thing that you are viewing now, you are showing now, this is one query. If you check what happens behind the scenes, in order for this chart to be rendered to your screen, it's one query. But we needed in that query to explain what we are aggregating. So all these menus that exist, the 3 nodes, 3 systems, 1 dimension, 2 labels, all this kind of stuff, you see that they have additional information. This is not part of the query. This volume percentage or the anomaly rate or the mean, average, maximum that you see there are per item. So if you go to something that's not the same, because these are fixed on all of them here, okay? So here you see that the system CPU pressure on New York is the volume of that thing is half the chart. This is what the volume percentage means. It is half the chart. So whatever you see as the chart, half of it comes from New York. And similarly, you can see on the minimum, average, and the maximum values, the points that were aggregated. So can you zoom out a bit? Instead of 15 minutes, go to, I don't know, a day or half a day or something. So now that it is a day, you see that Hugo saw the each as average of this. This means that every point that you see on your screen has 242 points of the database that have been aggregated here. 242 points on the database, 242 seconds in this case, have been aggregated to one point on your screen. Now, so the query engine touches all the points and aggregates them. There's also some complexity there because we have tiering. In this case, for example, you see that 10% below at the grade, the functions below lose accuracy, it says, the model that we saw. And we need to round this, come on, a lot of decimal points there, not decimal digits, yes. We have to round this. But you see that 10% is high resolution and 90% is tiered data. So the query engine behind the scenes also aggregated stuff, used the higher tiers to speed it up. So it used probably the last, because it's the last 24 hours, probably it used some of the last part, 10% of the chart from the high resolution tier, because the others don't have it. And everything else comes from higher tiers, from lower resolution data. So now, in order to render this, to do this query, we wanted to calculate all this information. We needed to know from which nodes it comes, from which instances, from what dimensions are there, what are the labels, and for all of these to have mean, max, average, anomaly rate, volume calculation, and all this kind of stuff. In order to do that, we had to rewrite the entire query engine of the data. So now the query engine does produce a chart, but it also gives you hundreds of additional data so that the UI is able to render the same or the entire chart with one query. All these drop downs and the likes, it's not additional queries. It's the same thing. So in one pass, the Netdata query engine calculated everything in order to give you the ability. Why this is important? because this gives you the ability to understand what's happening, where the data are coming from. Now, in this case, how to show you why this is important. So imagine, close this model, this drop down. So now you see, for example, go to something else. Go to.
You want one with anomalies? I think Andy provided one example with anomalies.
Provided.
Let me try to.
It's okay. It doesn't matter. The whole point, guys, is we tried to give visibility. So let's take this chart. This has in and out. Okay. Now, if you hover on the anomaly, can you zoom in a little bit on the anomaly rate? Not too much, but just a bit. There. Okay. Okay. Now you see that this ribbon there has the anomaly rate that we saw above the chart. This is when the trained model of these metrics decided that the exact values that are collected are outliers. They didn't happen before, in the last 24 hours in our case, because the trained model retrains, it's rolling, but it has a history of 24 hours. So what this says there is that this spike that we see on that chart, and if you hover on the anomaly, it will say on which dimension. Can you hover on the anomaly? Or you're hovering? You're hovering already. You see that the in direction has the anomaly rate. If you want to see from where this thing comes from, so go to the 3 nodes, please, drop down, and you see that the anomaly is coming from San Francisco. If you go to the 3 systems, again is the San Francisco. If you go to dimensions, the drop down next, you will see that it is input. And if you go to the labels, oh, we don't have this. This doesn't have labels. If you go to the disk, can you go to a disk? Probably there is go to the disks below. Yeah, the second, yeah, is the disk. Yes, drop down the labels. Now you can even see. Oh, it is one thing only.
Yeah.
No, it's only 5. I see the values that are always one. Drop down there. I want to explain.
Probably CPUs.
Yeah, but the CPUs will not have any significant labels.
Network.
But anyway, the whole point is that this calculates even per label the anomaly. So if you had 2 disks and one was virtual and the other was physical, the expanded, there you are, you have it there. Expanded this network
This
interface.
doesn't have anomaly rate. Yeah.
It's 0, the anomaly rate. Yes, I know, but can you expand the values, please? On the device, interface type. So you see that there are real interfaces and virtual interfaces. And on the device, expand the device too. These are the devices that are aggregated on this chart. Now, the whole thing has been built in a way so that by just seeing a chart, you can understand what data have been aggregated into this. I find this unique. This is an innovation that we did actually to allow all of us to understand what we are seeing. One of the biggest differences that we have, for example, in the data has with Prometheus and Grafana, is that Netdata does not assume that you know the metrics. We assume always that the moment you see a chart is your first experience with this chart. You have never seen it before. You don't know what it is. So when you see it, one of the key things is to explain to you what exactly you see so that you can trust the data and understand the data. So this was a crucial part, to be able to drill down everything in that detail so that by just seeing the chart, to be able to say what exactly you are seeing. This is unique, guys. This is, for example, if you want to do something similar in Grafana, you have to do a ton of queries to actually find all the numbers. Every number that is here is actually almost a separate query for Grafana to actually figure it out. Now, the next thing, there are two things that I want to say more. One is about these drop-down menus. These drop-down menus, we call them the needle framework, NIDL, needle. It goes with the needle in the haystack, but it's a different thing. So the needle framework is something that exists in Netdata from the very beginning. So when I started Netdata back in 2016, one of the things that I decided back then is that in order to have a reasonable presentation of what you are seeing, you need to have some context. The first thing that you need to know is which component or application or whatever is monitored. Which is this? So this is the interfaces, the 6 interfaces there. This is what it says. There are 6 interfaces. This is the instance part of the needle there, but it changes name per interface. So if you see network interfaces, it says interfaces. If you see disks, it says disks, etc., etc. So the instance is the most important thing that I believe provides clarity when you view monitoring data. Most of the other monitoring solutions, they don't have this concept. For example, even the current development of OpenTelemetry, they ignore totally that thing. And this is one challenge for us because we want to be OpenTelemetry compatible as possible. But unfortunately, the information we need is not baked into the data model. It's not there. So for us to understand what exactly you monitor with each chart is crucial. This, even for us, it was faulty in some cases. So if you go to the application section, you will see there that it says 3 systems. Wait a moment. This is not the components that are monitored. The components that are monitored are 14 applications. So 14 these are monitored. So actually, in order to be straight according to our values, these dimensions should be instances. This required this new dashboard. The old dashboard, mainly because it didn't have this capability, we decided to merge stuff together, like the applications, so all the applications in one chart, mainly because the dashboard would not be usable. You would have dozens of charts there, every instance a chart. So your MySQL CPU, your Nginx CPU, your application CPU, your kernel CPU, it will not be manageable to have just one chart per instance. So we decided back then that for the applications, we need to do it a little bit differently. Now that we have this UI, we plan to change the applications. So we plan to actually create one instance per application that will have all the dimensions and the labels and the likes. And then the UI will flatten them and merge them in order for you to view them. So this is the needle framework, and this is why this was very important, because understanding the component that you monitor at every given time, a database table, a database server, your disk, your network interface, whatever that is crucial. You need to have clarity on what do I monitor with this? At which level do I monitor that thing? The next thing is about grouping, pivoting the data. So when you pivot the data, one way is to see that go to a disk or a network interface, please. So now that you are here on the disks, wait a moment, close that thing, wait a moment. So here you see that you have 2 dimensions of the charts on this chart, reads and writes. Okay, these are aggregated. So you are viewing actually the sum. It says the second thing on the above the chart. It says that we are viewing the sum of all the dimensions, the 2 dimensions in this case, of 3 disks on 3 nodes. This is what you saw. And can you zoom out to a day again, please? Now, look how the query engine is a little bit complicated, but I will try to explain it. There are time series. The time series have values per second or whatever they are. So in this case, a day has 86,400 points. And you want to view them in, I don't know, 1,000 points. What's the window that the browser width that you have at any given time. So what we do is that we make a division. We say, okay, in order to see 86,400 points, 86,400 points into this many pixels, then we need to summarize each point. We need to summarize to each point 242 seconds of source data. Okay? This is dynamic. If you zoom in a bit or zoom out a bit, this thing changes. The next thing, is that's the first thing that happens. In this case, there are 3 disks with 2 dimensions each. This is 6 time series that are taking part here, 6 time series. The first thing that happens is that for each of these 6 time series, we do the first aggregation, the average every 139 seconds. Then once we have the final points that the dashboard wants for each of the dimensions, then we group them. We group them by default by dimension. That's the group by dimension there. So what you view by default is whatever the drop-down dimension says. If the dimension says has 4, if you see 4. If it has 1, you see 1. Still, there are a lot of metrics that are flattened, aggregated according to the sum, in this case, into the visible dimension. So we had 6, we need to present 2. Now, if you select different grouping, go and select by instance. Remove the dimensions, select the instance, the disk. So now we have 3 dimensions. These are the disks. We have 3 disks. What happens in this case? So in this case, we summed this in and out, reads and writes. We sum them per disk, and we give you here the sum. This is the total I/O, read and write per disk. Of course, you can slice it now. So go to dimensions and select only reads. Now this is sliced. Now out of the 6 dimensions, we select only 3 of them. Of course, you can do any combination you like. So enable again the second dimension and go to group by instance and select by device type and by dimension, 2 of them. Remove the disk. You have to remove the disk. Okay. Now what it says is, look what happened now. It says reads physical, writes physical. If we had a virtual disk inside, we will also have read virtual and write virtual. Probably you can do this in network interfaces. Can you go to network interface to show it? Mm-hmm. And do the same. Not device, go by instance. Remove the device. This. Okay. Now you see, oh, it's better to the way you had it before, because now it's the whole host name inside. Go to the device. Like this. So now you have real F0, virtual VPN 0. No, do it please with the dimension name, and remove the device. So now you have received real, received virtual, and sent real. The other one is not shown because there is no sent virtual in this case. It's 0. This is why it's eliminated. So guys, what this allows us all is to actually pivot the data the way we see fit. So any way we want to see them, this is here. The interesting part is that the query engine behind the scene has another capability that is not visible. The problem is that we couldn't find an easy way to visualize this. So the query engine behind the scenes can do another pass. So far we said two passes. One over time, every dimension across time to shrink it. The second is how you want to group them together. Now, the query engine has the capability to actually do another pass or even more passes on the data. This is used for the tiles. So if you go at the top. So at the top here, for example, you have top nodes by use drum. So now what we have done is three passes on the data. One is an aggregation over time. The second is an aggregation across instances, and then a maximum, for example, for instances on nodes. So if you had, for example, disks or network interfaces, you can say, okay, first aggregate per network interface, and then give me the maximum of each node. So, but this is too complex. It started becoming too complex, and it's crazy to think how you can have a user interface for this. Probably it needed a pipeline of stuff that we haven't rearranged. And the next phase of this work is to actually go and expand the charts. So today, if you go again to where did we see this anomaly?
I think it was one of these above.
Yeah, anyway, it doesn't matter. So we have cases here that, for example, you have 20,000 containers on a chart with 2 or 3 dimensions each. And suddenly you have somewhere an anomaly like here. Imagine not being 3, but being the systems, but being 2,000 or 30,000. What do you do? How do you find this anomaly? So you need to be able to identify the anomaly that exists. In order to do that, you can do it from the drop-down menus. It's not going to be easy, especially if there are a lot of data, then they are aggregated and the numbers become very small. But the whole point is that we wanted a way to actually identify that immediately. So we have designed, but we interrupted this work in order to release and to continue later. We have an expanded view of the charts. So the bottom of the chart becomes a little button that says expand. You click it, the chart becomes twice in height. And inside the bottom part, now you have tools to actually help you analyze the data. One of the tools is to actually drill down by instance or by dimension. So I want to just drill down. Show me all the instances or show me all the dimensions in a table, so that, or even in charts, I want to see them and probably sort the table in a different order and find what I'm trying to find. The second thing is to allow you to compare, find patterns in what you see against the past of the same chart. So this spike, for example, you could say, hey, check last week and tell me when something similar to this has happened. And it will give you a number of occurrences that something like this has happened, scored by similarity. The third tool is correlate this, try to tell me for this spike that I see here, what else is related outside this chart. So this is like the metric correlations that we have today, but more focused on the exact pattern that we see on this chart. The same with the anomaly advisor. So the whole point at the end of the day is that the tools, the metric correlations tool and the anomaly advisor will be part of the chart. Every single chart will be able to do metric correlations and anomaly analysis. This is coming. I hope that in the next few months we're going to have it. This is pretty much what this is. So releasing this thing was crucial mainly because we have now the ability to change all the charts and apply the needle framework everywhere. It also one thing that we realized is that a lot of users have stuck actually with a very old version of Netdata, and they are not aware of the developments that we have done. So for me, it was crucial to bring this dashboard out, mainly because all the effort that we have put, all this time, went into that dashboard. So all the UI that we were building was that dashboard. And it was a shame that the agent had a very old, a very limited dashboard compared to this. Together with this release, it was planned something also very good, to my opinion, that unfortunately didn't make it. I hope that we're going to have it next week. So the thing that we missed to include in this release was a marketplace, a plugins and integrations marketplace, that you can see everything that the Netdata can do. At the same time, we have a team of engineers working on bringing life to these integrations. So instead, you want to monitor Postgres or MySQL or Nginx or whatever, and Netdata did not detect it, or it could not connect or whatever. Instead of going to configuration files, editing configuration files, restarting the data to see the result, to have on the UI, select MySQL, put the endpoint there, the username and the password, press a button, and boom, activate. This is also something very important. Another aspect, I hope that this will be in September, so the online activation. Another thing is about password protecting the data. Mainly because Netdata is distributed, password protecting it's a challenge. So if we go the traditional way, we have to interface with LDAP servers and this servers and that servers and do single sign-on per agent and all this work. Another approach is to use, and we have implemented this for functions. If you try to use functions on this version, instead of integrating all this stuff into the agent says, okay, I want a token, but I will give this token to you only through Netdata Cloud. So you have to pass the security mechanisms of Netdata Cloud to actually talk to me, to give you a token through Netdata Cloud. And if you manage to get it, then call me directly with a token as an authorization bearer, and I will serve the request. This happens for functions. So functions today do not travel through Netdata Cloud. It's direct between your browser and the agent. But through the cloud, the request is made to get an authorization bearer, a token from the agent, which the web browser then gives to the request it does or to the agent, in order to ensure that you are authorized to view this sensitive information. Functions, guys, are sensitive. The problem with functions is that, unlike everything else that is just metrics, and anyway, these are not very sensitive data, functions do provide, we have a journal, a systemd journal plugin almost ready, that I hope we're going to release soon. This will allow you to actually investigate the system logs, see the logs from the UI. We have also the processes that you can have the top-like view of what processes are doing it, sort by CPU, by memory, by disk I/O, by number of open files, etc., etc. A ton of columns there to actually work with. So all this work, we believe it's sensitive, so it should be protected somehow, and this is why we decided to go through this mechanism of the data cloud. Another thing that's coming is claiming. So today, in order to connect your agents to the data cloud, you have to run these commands that you get from the cloud. The new UI will support claiming from the UI. So you go to an agent, you install it, it was not claimed, not connected to cloud, you sign in, and then it says, okay, let's claim this agent. And you are able to claim it. Again, we want something from the system because the key point in order to claim an agent is to verify that you are an administrator of that thing. So what we do there is that we generate a token on disk and we give you a command to just cut this token and copy and paste it. This way we verify that you are an admin of that machine, and then boom, everything goes and the node is claimed. Now, apart from all this dashboard work and the things that are coming, we have also released the assistant. The assistant is not interactive yet, so you cannot chat with it yet. But the idea is that it knows all the alerts, it knows all the things on what is the alert, what does it mean, etc. The whole point is to help you troubleshoot your system, fix your system. This is released. I think this is available only if you sign in, right?
Yeah.
Yes, because the APIs and the assistant, the entire logic is on the cloud. And also, we rewrote the hardware sensors, the IPMI thing, completely to make it more robust. This thing is very slow in the kernel. It's not our fault. It's the IPMI protocols and the likes rely on polling sensors and the likes. It's not giving your value. They ask and ask and ask all the time until this succeeds, and it's a strange thing. So it has both increased CPU, not for us, it's a kernel CPU, and it is slow. We managed to decouple it so that this thing is now multi-threaded, it's a lot faster, it's a lot more reliable. And we also categorized all the sensors. Through this categorization that you see there, processor, memory module, storage, motherboard, etc., is not baked into the IPMI protocol. We had to pattern match built an expert system there to pattern match the sensor names in order to provide this or extract this from various other sources. So this is the release, guys. This is what we did.
Probably this could be important also, the labels, right? To extract the sensor name.
We added also now we are adding everything, guys. Now that the dashboard, we have the dashboard of the agent that supports everything. Now all the work we do is according to the needle protocol framework. So we try to make everything per instance, to have to know which component is monitored, to have all the labels that are required, even the things that we merged today about the EDAC, about the memory, enterprise memory modules error correction. Even that thing that we merged today has all the information that you could find in proc about what is this memory module, what is speed, what is size, everything that you have there, everything is labels. And it is also per instance. So we added one per memory, two charts, one per memory controller and one per DIMM. So we're able to manage to have error control per DIMM. That's it, a lot of work, fun work.
This last one, you want to speak about the file descriptor, the leaking,
yes,
to get the limits of the open limits on the file descriptors.
One of the things that we wanted to improve, and this is important, guys, where the apps plugin monitors all the process of the system. So this thing could detect memory leaks, file descriptor leaks, whatever, all the stupid stuff that happened in applications, we could build logic to detect it. Now, in this case, what we did is that we added, apps plugin was already monitoring file descriptors and sockets and all this kind of stuff it was already in. But what we added is that we added the ability to check the limits of the process, read the limits, and then check the actual used file descriptors against the limit. And we created an alert. I think it is disabled because we found a bug. There were a few users that complained that this spikes a lot higher. So we added debugging, and we expect some feedback in order to see why this happened, what's wrong, to fix it. But anyway, the whole point with this is that we want people to enjoy, to trust, or use Netdata actually to detect common issues. These, let's say, best practices about monitoring stuff, guys, are very important for us. So this was suggested by a user. And it's obvious that, of course, we can do that. It's easy to accomplish that task. I think there are many, many, many more stuff. So this is why we changed also the README page on GitHub to actually explain this to users, that we want this kind of feedback. The feedback that says, hey, why don't we do this in order to detect that issue, the other problem, or et cetera, et cetera. This is very important. We cannot know everything. And this is a very broad technology. Monitoring is vast. That's it, I think.
Yeah, I think now it's more just the acknowledgments and contributions, but I think the kind of the next important thing is still the deprecation. So deprecation notice for the, I think it's, we are planning for this to be deprecated on this actual version, but this actual release, but it was not possible to achieve this. So this is going to be deprecated on the next release. So we are going to move the NVDSME from the Python collector to the GoD, and also the family attribute that is used on the alert configuration, the else API, is going to be deprecated and start to use chart labels instead of the family. The stock alerts are already not relying on this, but we still need to have the else API taking care of this instead of the family to use the chart labels. And yeah, I think that's it. So probably we can check if are there any kind of questions or any kind of comments anybody would like to raise.
Any
Checking the
problems,
chat.
guys, that you may have and you want to discuss? Any issues that you face? Any unknowns that you want to clarify?
Seems that for now, no. But yeah, we also have our Netdata office hours next Wednesday. So if in the meantime anything comes up, you would like to bring some topic or anything, feel free to jump into the Discord channel or drop a message, and we'll gladly tackle anything you throw at us.
Thank you, guys.
Thanks for being here with us, and see you soon.
Bye.
Bye.